Alright, welcome back. This is our first lesson on simplifying radical expressions. And these videos that I'm making right now are for those of you that are out on snow days. And I just want to say I hope, number one, you guys are enjoying your break. I know I have. It's fun to actually have a little snow in Virginia and be able to enjoy some time off from school. But I want to say this. We don't want to get desperately behind, so it's very important that you complete these assignments. Now I'm going to say this. You get 2 grades for each video. You get a homework grade for completing the 5 problems, and I've not labeled these videos optional or extra credit. These videos are required so that we get back on track. But the 5 homework problems get you a homework grade. So you guys get a homework grade for the homework, and also you get a quiz grade for taking notes on the video. Now, I'm not going in depth on these videos. This is very surface level, so I just want you guys to get the concept of what's going on, and when you get back into class, I will go more in depth and show you guys more detail about what all this means. But right now, I just need you guys to get concepts. So 5 problems, they're pretty short, simple. But today we're looking at, again, laws of exponents. We're finishing this. And what are we doing with radical expressions? We are what? We are simplifying. Now, reminding you on laws of exponents. If we have x squared multiplied by x to the third, if the bases match, we add the exponents, we get x to the fifth. Now, if we have x to the fifth divided by x squared, remember we subtract the exponents. 5 minus 2 gives x to the third. So we have addition of exponents, we have subtraction of exponents. And if we have x squared to the third power, remember power of power, we multiply, we get x to the sixth. So you're looking at addition of exponents, subtraction of exponents, multiplication of exponents. What was missing? We were missing division of exponents, okay? Division of exponents, and that is what we're covering now. Division of exponents. So we're finishing the laws of exponents. Remember that laws of exponents refer to what operation? Operation of multiplication. So go ahead and write this and star this. Operation of multiplication. So radical expressions refer to operation of multiplication with respect to, I should say, they refer to operation of multiplication because we're filling in the last portion of the laws of exponents chart, division of exponents. You guys learned in elementary school division of 6 divided by 2. 6 divided by 2 gives 3. This was elementary school division. Now we're looking at high school division or radicals. Square root of 16 is, you were told, square root of 16 is 4. Today we're going to investigate why. Now, very quickly, let's look at this fancy division symbol. So we're not doing elementary school division, we're doing fancy division. So we're looking at here. This is square root. This is cubed root. Fourth root. Fifth root, sixth root, and so on and so forth. Now, what are we dividing by? Well, if I say 6 divided by 3, we get 2. Okay, this is where the division or the divisor lies. Now our divisor lies here. Okay, so we're going to divide by 3, divide by 4, divide by 5, divide by 6. What do you think that this unwritten number is? Here, 6, 5, 4, 3. What is the unwritten number? Okay, we say for square root, the unwritten number is a 2. Do we actually write the 2? No. It's assumed that it's sitting here, but we don't actually write it. So here we're dividing by what? Dividing by 6. Here we're dividing by 5. Here we're dividing by 4. Here we're dividing by 3. And up here where there's no number written, we're dividing by 2. Okay, so dividing by 2. The number is unwritten. So again, the divisor was large when we did elementary school division. Now the divisor is very small. Why is it small? Because what are we dividing? We are dividing exponents. So let me show you very quickly a short example. If we're looking at the cubed root of x to the 9th, y to the 12th, this is really all that you have to do. You are dividing what? You are dividing exponents. So you're going to take each exponent and divide by 3. So we get x, this is the same as x to the 9 divided by 3, multiplied by y to the 12 divided by 3, and just simply divide your exponents. 9 divided by 3 gives x to the third power, 12 divided by 3 gives y to the fourth power, and you are done. So you are simply dividing exponents. Now, let's look at 4 little examples that I've created here, and we'll be done with this video. Okay, so we're looking at the 5th root. This is like your homework problems. The 5th root of 243, a to the 20th, b to the 25th. Now, since we're dividing exponents, guys, my question is this. Are we taking 243 and dividing by 5? No. You are not taking the number and dividing by 5. No, absolutely not. Let me write that 5 a little bigger. This is the fifth root. We're not taking 243 and dividing by 5. We're taking the exponent of 243, and what is it? It's a 1. Okay, we're taking the exponent of 243 and dividing by 5. But since the exponent of 1 does not divide evenly by 5, we're going to take the 243 and break it down. So I'm going to erase this. All right, we're going to take the 243 and break it down. So 243, we're going to break it down into what we call a product of primes. Now the numbers that you need to divide by here, divide by these numbers. Divide by 2, 3, 5, or 7. Always start by trying to divide by 2. Okay, notice, a number is divisible by 2. We know this if it is even. Now is 243 an even number? No, it's not. It's an odd number because 3 is an odd number. Okay, so 2 is out. We cannot divide by 2. But can we divide by 3? The trick for checking for divisibility by 3, the answer is yes. 243 is divisible by 3, but how do we check this? We add the digits. What is 2 plus 4? Add the digits up. 2 plus 4 gives what? 2 plus 4 gives 6, and 6 plus 3 gives 9. Since the digits add up to a number, 9, which is divisible by 3, this means that 243 is divisible by 3. So we do it again. 2 plus 4 is 6, plus 3 is 9. Since 9 is divisible by 3, 243 is divisible by 3. So write 3. 3 times what? If you need to, I'm okay with you guys using a calculator, but I'd rather you guys not use a calculator right now. 243 divided by 3. I would rather you at least do something and not give up on this, guys. 3 goes into 24, what? 8 times. 8 times 3 is 24. Subtract, we get what? A 0. Bring down the 3. 3 goes into 3 once, so we get 81. Now, can we divide by 3 again? Yes. 8 plus 1. 8 plus 1 is 9. And since 9 is divisible by 3, 81 is divisible by 3. So take 81, divide by 3, we get what? We get, 2. 2 times 3 is 6. Subtract, we get a 21. Bring down the 1. 3 goes into 21 7 times, so we get 3 times what? 27. Now you can keep going. Divide by 3 again. I always think students will stop here and say, well, 81 is 9 times 9. Yeah, that's fine. You can get 9 times 9, get 3 times 3, 3 times 3, that's fine. But I would rather you guys stick with the same division. So if you divide by 3, try to keep dividing by 3. Divide by 3 again, we get 27. Divide by 3 again. 27 divided by 3 is 9. Divide by 3 again. And this allows you to be able to read it a little easier. If you keep dividing by the same number, the 3's run in a nice line. You can count how many 3's multiply to give 243. 1, 2, 3, 4, 5. So we're saying that 243 is equal to what? 3 times 3 times 3 times 3 times 3. Since 243 is equal to 5 3's multiplied together, we can rewrite this as the fifth root of, take the 243 out, and replace it with what? What is 3 times itself 5 times? Replace it with 3 to the 5th power. This is 3 times itself 5 times, a to the 20th, b to the 25th. And now take each one of your exponents and divide by 5. So we have 3 to the what? Remember, we are dividing exponents, so we're going to have 3 to the 5 divided by 5, a to the what? 20 divided by 5, b to the what? 25 divided by 5. Divide each one by 5. 5 divided by 5 gives a 1, so we get 3 to the first. Do we need to write the 1? No. Just write 3. 20 divided by 5 gives 4, so we have a to the 4th power. 25 divided by 5 is 5, so we get b to the 5th power. And we are done. So that's all there is to this problem. That's probably the toughest type that's up there. Next. Okay, so we're looking at this example. 3 more examples and we're done with this video. Okay, so the next example is the square root plus or minus the square root of 121, x to the 4th, y to the 6th, z to the 12th. Now, I tell students this. Okay, you see this plus or minus out front. You see this plus or minus, just ignore it. It's going to just hang around. It's just going to hang around the whole problem. So just ignore it. It's not even, don't even pay attention to this plus or minus that's out front. I want you to just pay attention with what's on the inside. So we're going to take the number. The first step is to take the number 121 and factor it down. Now I said to divide by numbers 2, 3, 5, or 7. Every once in a while you get a number that's not divisible by any of these. 121 is an exception. Okay, so these are called prime numbers, 2, 3, 5, 7. The next one is 11. It's very rare that a number is divisible by 11 in this class, but 11 is what we use here. 121 is what? 11 times 11. Okay, so that was just an exception. 11 times 11. Now, 11 does not break down anymore, so we're done. 11 is called a prime number, so we have plus or minus the square root of what? 11 times 11 is 11 squared. X to the 4th, y to the 6th, z to the 12th. And now we're going to take each one of our exponents and divide by what? What is the unwritten number sitting here? Reminding you, square root, cubed root, fourth root. Okay, what's the unwritten number here if it's not written? It's a 2. Okay, so the unwritten number is a 2. Do we write the number? No. It's just sitting there and we understand that we're dividing by what? Here we're dividing by 3. Here we're dividing by 4. If the number is unwritten, what are we dividing by? We are dividing by 2. So what are we dividing all of the exponents by? We are dividing by 2. Now, so we're going to write 11 to the what? 2 divided by 2. 2 divided by 2. X to the what? 4 divided by 2. Y to the 6 divided by 2. And students say, do I have to write this? Yes, I want to see this step for now. Z to the 12 divided by 2. And now divide each exponent. 2 divided by 2 gives 1, so we get 11 to the first power. Do we have to write the 1? No. We get x to the 4 divided by 2 is x squared. 6 divided by 2 is 3, so we get y to the 3rd. And 12 divided by 2 is 6, so we get z to the 6th. Now, students, if you finish here, this answer is wrong. This answer is wrong. Why is it wrong? Because, okay, so this is a little, pay close attention to this. If the index is even, and the exponent is even, you have a case of possible absolute value. Even divided by even gives odd. Okay, even divided by even gives odd. Now, so we have 2 divided by 2. 2 divided by 2 gives what? 2 divided by 2 gives 1. So we got even divided by even gave odd. Now here we have even divided by even. Even divided by even gives even. Okay. Here we have even divided by even gives odd. Every time you have even divided by even gives odd, you get absolute value. So we have an absolute value around the 11. And we have absolute value around the y cubed. Why do we have absolute value around these? Well, because we had even divided by even. 2 divided by 2. Both of these numbers are even. Even divided by even give an odd of 1. Okay? Odd exponent of 1. Since even divided by even resulted in odd, we get absolute value. Even divided by even gives even is no absolute value. Even divided by even gives an odd number 3. We have even 6 divided by even 2 gives an odd 3. This is absolute value. 12 divided by 2 is even divided by even gives even. This is no absolute value. So we're looking for even divided by even gives odd. Okay, even divided by even equals odd gets what? Absolute value. Okay, it gets absolute value. So we put absolute value around the y cubed or absolute value around the 11. Is the absolute value around the 11 necessary? No, it's not. Because 11 is already a positive number. Because the absolute value of 11 is what? 11. We get x squared, absolute value of y to the 3rd, z to the 6th, and you're done. What did we forget? We forgot the plus or minus. The plus or minus is just sitting out front. So your final answer is this. Okay, plus or minus sitting out front. Let's look at another one. Okay, what if we have an odd index? What if we have an odd index of, say, cubed root? Are we going to have to worry about absolute value here? No. We never have to worry about absolute value with an odd index. We only have to worry about absolute value when we have an even index, like a 2. Okay, so here. When do we have to worry about absolute value? Here's square root, here's cubed root, here's fourth root, here's fifth root. Okay, we have to worry about absolute value here. When we have a 4 or a 2, when we have even index, we call this the index. All right, when we have even index, we worry about absolute value. If we have an odd index, like a 3 or a 5, you do not have to worry about absolute value. Now let's look at the next example. So looking at plus or minus, remember this just sits out front, the cubed root of quantity x minus 2 to the 6th power. Now students, reminding you, quantity x minus 2 to the 6th power. Okay, does the exponent distribute over addition? No. We write this how many times? We write this 6 times. X minus 2 times x minus 2 times x minus 2 times what? X minus 2. X minus 2. X minus 2. Okay, this is a monster problem. Remember, exponents do not distribute over addition. So how do we deal with this problem? Well, our goal is to what? Our goal is to simplify or to add, subtract, multiply, and divide until we cannot do this anymore. Take your exponent 6 and divide by 3. So we end up with question. Are we going to have absolute value here? No. Remember, we have to have an even divided by even. Notice, 6 is even and 3 is odd. So we will not have to worry about absolute value in this case. So we end up with what? We write the quantity x minus 2 to the what? 6 divided by 3. 6 divided by 3. And just now divide your exponent, you get plus or minus what? Quantity x minus 2, and 6 divided by 3 is a 2, so we get squared. Now, are we done? Remember, we are simplified, so we add, subtract, multiply, and divide till we cannot do this anymore. No, we're not done. We write what? Plus or minus, and exponents do not distribute over addition, so we write this twice. X minus 2 times what? X minus 2. And now FOIL. Take the first term, multiply by both, so we get plus or minus. Use parentheses here because this plus or minus is sitting out front. So we have x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Combine what matches. Remember, now we're done multiplying, we are now adding, so add what matches. X squared, since negative 2 have the same side, this is negative 4x plus 4, and put your plus or minus out front, and you are done. Okay, so remember, we divide the exponent first, we end up with a 2. Notice this is quantity squared. We write it twice and we FOIL. Okay? Last example. Question again. Do we worry about absolute value when we have an odd index? No, we don't. Okay, we worry about absolute value when we have even index. So let's look at the next example. Fourth root of 16 x to the 12th y to the 16th power. Okay, do we have to worry about absolute value here? Yes. Okay, because we have an even index of 4. So we could possibly have a case of even divided by even giving an odd result on our exponent. Okay, so let's look. We start with the 16, we break this down. We look at the numbers. What numbers need to go into, are we going to try to divide by? We're going to try to divide by either 2, 3, 5, or 7, or sometimes 11. So what goes into 16? Well, hopefully you see 2 times what? 8, which is 2 times 4, which is what? 2 times 2. How many 2's multiply to give 16? Let me do that a little slower. Again, if you guys are struggling with the factoring, 16, we see that it's even, so 2 goes into it. 2 times what? 8, which is what? 2 times 8 is 2 times 4. 4 is what? 2 times 2. So how many 2's multiply to give 16? Hopefully you say 1, 2, 3, 4. So we're going to write this as the fourth root of what? 2 to the 4th, x to the 12th, y to the 16th. And now we take our exponents and divide by 4. Okay, so we're looking for what? Even divided by even resulting in odd. Okay, so we're going to write 4 divided by 4, so 2 to the what? 4 divided by 4, x to the what? 12 divided by 4, y to the 16 divided by 4. Do we have even? Yes, even. So any of these could possibly be absolute value. Now, 4 divided by 4 gives an odd number 1. So we have 2 to the first power, which is an odd exponent. Does this get absolute value? Yes, it does. However, is the absolute value of 2 the same as 2? Yes. The absolute value is unnecessary because absolute value, we already know that 2 is positive. So there's no need to put absolute value around it because the absolute value of 2 is the same as 2. So there's no need to put absolute value around the 2. So we get what? Just 2. And 12 divided by 4. 12 divided by 4 gives 3, so we get x to the third. Did we have even divided by even resulting in an odd? Yes. So go ahead and put absolute value around this. And 16 divided by 4. 16 divided by 4 is 4, so we get y to the fourth. Notice we have even divided by even. However, the result is what? The result is even, so this does not get absolute value. And I will explain all of this when you guys get back. I just want you guys to be comfortable with the concept of, or know when we use absolute value at this point. So we're looking for even divided by even resulting in an odd exponent where? Around our variables. So the rule is this. Only put absolute value around your variables, either your x term or your y term, or your a term or your b term. All right, so that concludes this video. Great. Good luck on your homework, guys.